So we've been working on similar triangles, and so what we're going to do today is give you some different postulates that will decide if you have similar triangles, and then you will have some proofs that you will have to do at the end of this. So the first postulate is the angle-angle similarity postulate, which just says that if I have two angles congruent, remember that I need congruent angles for them to be similar. If I have two of them, then I automatically can conclude that they are similar. So we're going to practice just that on this first piece here. And it says, are your two triangles similar to each other? And it has this figure to the right here. They tell me that angle R and angle V are congruent, so I know that just from the picture. But I also know that angle WSR and angle VSB are congruent by vertical angles theorem. So now I have two angles that are congruent, so now I can say yes, they are similar by angle-angle similar postulate. Let's take a look at another one. So it's asking me, are these two triangles similar? Well, they gave me 30 and 70 and then 70 and 85. I went ahead and find the third angle in each of those triangles so that I can see if I have two matching, because currently from what they gave me there were not two. So after I found the third angles, I did not see any two angles that were congruent. So this would be no, because I don't have two angles that are congruent to each other. Why don't you pause the video and see if you can do the got it question. On the got it question, the first one, I went ahead and found the third angle over here so that I could see if I had two congruent angles. Once I did that, I did find that I had two 90-degree angles and then two 51-degree angles. So yes, those triangles are similar by angle-angle postulate. Then for your second one, I went ahead and found my missing angle measurements. Now this one's a little bit more tricky. These are isosceles triangles, so I first know that these base angles are congruent. So if this is 68, this one is also 68. And then I just subtracted both of those from 180 to find this third angle. Over here, again, these two angles have to be congruent. So I would take 180 and subtract away 62, but I would have to divide by 2 to figure out what one of those angles are. After doing all of that math, I did not see any two angles that are congruent. So this one would be no, because I don't have two angles that are congruent to each other. Okay, so we're then going to work on the next part, which is two more similarity theorems. The second one is side angle side similarity theorem, which just is very similar to the side angle side theorem that we did. You have to have an angle congruent, and then your sides have to be included between that angle. But the difference is my sides are not congruent. Remember, for similar, I need angles congruent, but sides proportional. So as long as you have an angle congruent and the sides surrounding it proportional, then my triangles are congruent, or similar, I'm sorry. The other one is side-side-side similarity theorem, and that just says that if you have all three sides that are proportional to each other, then I can say that my triangles are similar. So when I say proportional, I mean corresponding sides. When you match up those ratios, all of those ratios have to simplify to the same thing, so the scale factor is the same. Okay, so let's put that to some use here. So the first one, it asks us, are those triangles similar? And if so, you're going to write a similarity statement. First thing that I did is I went ahead and made these in the same orientation. I'm very visual, so I went ahead and made them like that so that I could just see it. I went ahead and found all of my ratios. So I just matched up by shortest sides, longest sides, and then went ahead and did the last sides. You can also do it based off the orientation, so if you want to set them up exactly the same and then match up corresponding sides, you can do that too. So shortest sides came up with reducing to 2/3. Longest sides were 10 and 15, so they reduced to 2/3, and then the ones that I had left over were the 8 and the 12, so they also reduced to 2/3. So since all three sets end up giving you the same scale factor, yes, these would be similar by that side-side-side postulate. The second part of the question was asking about giving a similarity statement. So this is where it's important that you match up the corresponding angles. So if you start with triangle STU, so I went from S and then I went counterclockwise. Then over here I have to start with the corresponding angle, which is X, and then go counterclockwise, so XVW. Now remember, there are lots of different ways you can write this. You just have to make sure that you match up those corresponding angles. Okay, next one. We have a different kind of picture. Notice that we have overlapping triangles. So you want to go ahead and separate those out. So I put this smaller one to the left, I put the bigger one to the right, and then I matched up my lengths. So the smaller one had 8 and 12. Now for these bigger ones you would have to add these two sides. So I would have to add 8 and 2 to get km. I would have to add 12 and 3 to get kn. Then also notice, so since it's overlapping, that this angle is the same on both of them. So that's the reflexive property, where both of those angles would be congruent to each other. So this would be applying the side angle side similarity postulate, where if you can prove that these corresponding sides are proportional, then I could use that to say they are similar. So I went ahead and matched up my ratios. I set up 8 and 10 and got 4/5. I set up 12 and 15 and got 4/5, so they are proportional. I do have the included angle congruent, so yes, those would be similar to each other. And then again, for my similarity statement, you want to make sure you match up corresponding angles. So I went K and then clockwise this time, so KLP. So then I got to start over here with K and then go clockwise as well, so KMN. Alright, pause the video and do the got it question. Okay, within the got it question, you had two sets of triangles. On the first one, I said yes, they are similar because I end up getting all three sides proportional to each other. For my similarity statement, I did triangle ABC similar to triangle EFG. So you just need to make sure that you have A matched up with E, B matched up with F, and C matched up with G as you write your similarity statement. Letter B, I went ahead and drew them out so that I could see what I was working with. I went ahead and saw I had an included angle, so I want to check to see if my sides are proportional. So I did 8 to 16 and 6 to 12, both of those reduced to a half, which means they are proportional. So this one is also yes. And my similarity statement, I did ALW is similar to the triangle ACE. Okay, the last piece here is where we're going to do a proof. And I know you guys hate proofs, but at the same time, these are really not that bad. Okay, they're very similar to those triangle congruent theorems where you have to spell it out. So you're trying to do angle, angle, side, 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 or side, angle, side for these similarity ones. So you're going to go ahead and set up your two columns. In the first row, you want to go ahead and write in your given, so that's what I did first. Then I want to start analyzing what else do I know. So based off the picture, they show me that this is an isosceles triangle. So on both of them, I know that these base angles have to be congruent to each other. Well, if these base angles are congruent to each other, then that means that they also have to be congruent to the other ones. So I said that angle H had to be congruent to angle L based off the isosceles triangle theorem. And then bam, all of a sudden I have two angles congruent, so I know those two triangles are similar by angle-angle similarity postulate. Pause the video and see if you can do the last proof in the got it question. Okay, in the last question, the only thing they give us are that these two lines here are parallel to each other. So what I would want to infer is, first thing is I see that these two angles are vertical to each other. So I know that those two angles are going to be congruent. So angle CBA and angle PBM are congruent by vertical angles theorem. Next thing, they gave me these parallel lines, so I know I have to use them somehow. So I said that this angle has to be congruent to this angle, so C and M, by alternate interior angles theorem, just because that goes back a while when we talked about alternate interior angles. And then as soon as I had those two angles, I said the triangles were similar to each other by the angle-angle similarity postulate. So what you're seeing from this lesson is that you're going to be focusing on proving that triangles are similar, either using angle-angle, side-side-side, or the side-angle-side. So those are the only three for similarity postulates. Now start your assignment.